Welcome, after quite a long gap, to Britjet's PSX tutorials for the Aerowings PSX 747-400 desktop simulation. Primarily, you will see pretty pictures from other products in here just to jazz things up a bit. Guys, please don't use this professionally. I'm sure you've got much better resources than me for getting you through your checks and training. So moving on, for the PC guys, the guys who are having fun, we are going to look at low visibility operations. Now by that I mean takeoff with a visibility of 400 meters or less, or 550 meters required for landing. And the focus will be on low visibility procedures as used in a generic airline who know where I live and pay my pension. Other operators, of course, may differ. We're going to use metric. I'm not going to use feet. It goes on forever. So I'll keep the video short. So apologies to our American cousins. I think this is my favorite slide, actually. I'm not sure why. I think possibly I have a thing about socks, don't know. Moving on though, we're going to do chronological from the gate departure to landing. Now, a word of warning here, some of this stuff is a little dry and probably over the top for PC simulation. I could jazz it up with cool music and lots of jokes, but the truth is that low vis ops are nowhere near as exciting as the Red Bull Air Race, so feel free to skip on if you feel your eyelids getting heavy. You will see some slides which I will gloss over. Those of you that want to refer to them, feel free to freeze it and get from it what you will. Anyway, here goes. Now, low visibility operations are a bit of a minefield. They require an in-depth knowledge of the regulations and the requirements, and line pilots will be very familiar with the sort of mind games that are played on their recency checks, where there is a Q&A session usually on all the things that can go wrong, all the things that you have to think about for a low visibility operation. I'm not going to go through them all. I may touch on some of them. If you want to know more, I'm sure there are lots of references out there. First of all, chronologically then, can we take off? There is a thing called the takeoff alternate down here, sometimes called the return alternate. Now, if you are going to take off, something goes wrong and you are unable to continue your sector, you might want to land back from where you came, or you might want to divert quite quickly somewhere else. The requirement is, if you can land back where you just took off from, with the aircraft as it is, which might well be capable of a Category 3 landing if the airport can support it, great. If not, then you are allowed to go for 2 hours flying time, which is deemed to be 800 miles on a 4-engined aircraft. And if you can find somewhere within 2 hours flying time, again, where you can land with the aircraft as it is, might be Cat 3, great. Now there is a slight proviso to this, which is that our cousins in the United States, Canada, and the gentlemen in Saudi Arabia have slightly more restrictive rules. They don't really agree with us zooming off for 800 miles and then trying to do a Cat 3 landing with an engine failed or whatever. They require a forecast at the takeoff alternate, which in general would have a 600-foot ceiling and 2 miles visibility. It depends on what kind of approaches are available and how many approaches they have. But that's just something to think about. So they are a little more restrictive. Coming back to the takeoff, we've decided we can do that bit. Now, point 2 here would be the minima for takeoff. Now, you'll find those in the plates for Lido and Jeppesen. Typically, it will be RVR at these limits. But one interesting thing is the ceiling might and almost certainly will be 0. I mean, fog is cloud on the ground after all. It can be sometimes more than 0 if, for example, you need some sort of visibility requirement for a second sector climb out, like if there was high ground around or an obstacle, but generally the ceiling is at 0. Having sorted that out, you might just want to make sure that the aircraft is serviceable. The only thing I can think of that would really restrict you would be an unserviceability of the PVD, in other words, the paravisual display. it's only referenced to the captain's side because he's the guy that's allowed to do the takeoffs in these situations. And if the PVD was US, then you wouldn't be able to take advantage of any reductions it might be able to give you. And in fact, in the USA, they don't recognize its use anyway, which is a bit strange considering that they designed the thing, but there you go. So let's assume then we have gone through these three items and we've decided that we can, in fact, take off. Lovely boring stuff coming up now. Here we have runway visual range measured by a device called a transmissiometer. In fact, there's usually 2 or 3 along a runway, and often this RVR value will be on the METAR like the one above. Now, of course, in PC simulation, we don't have this 2 or 3 position reading of the RVR, but I'm including this in the slides so that those that want to learn more in depth can do so. You wouldn't normally find out about your midpoint and rollout RVRs until you're actually on approach. The only thing you'll find in the METAR, as for example this one here for Stockholm, would be the touchdown RVR. So here we have a METVIS of 200 meters, runway visual range 19 right, 250 meters, U, meaning going up, increasing, or one left the other end, 300 meters, decreasing, going down. So let's suppose we wanted to land a 19 right, we would have an RVR of 250 meters there. That's the touchdown zone. Now there are 3 zones typically, the midpoint and also the roll end. So let's look at these in a little bit more detail now. More boring stuff, sorry about this. The takeoff RVR minima is fairly clear cut. There is a slight caveat to this, which is that if the pilot decides to taxi out to the end of the runway and he finds when he gets to the runway that he can actually see as far as or further than the RVR they're quoting, he's actually allowed to take off, which is a bit of a funny one. I just mentioned that in passing. Now the midpoint RVR here, you see I've got 125 meters written in. We have to have 125 meters in the midpoint, or we can have a lower RVR if we've set off with lower RVR minima in the first place. Why is that? Why do we have these two things? Well, the reason is that if you're using one of these gadgets like a head-up display or a PVD, that will enable you to reduce your RVR for takeoff so that the thing is assisting you on takeoff for directional control. If you haven't got that and therefore your minima are higher, they assume that you are doing some sort of a manual takeoff, and it is deemed that 125 meters is really about the minimum that you can control an aircraft at speed as it's going down the runway. So that's why they ask for 125 meters as a minimum unless you're taking off with less than that to start with. And the stop end at the far end is advisory. Usually you can ignore it. It may be needed in certain circumstances. Very rarely seen, certainly not for a 747. So moving on, a bit more mind games now. The guys coming on the simulators regularly, they will be well used to this. The trainer or instructor will give them a certain mind game to play with. There's an example here. I'm not going to go into the details, feel free to freeze the frame, but basically you have to think about what your runway visual range is for the touchdown zone and also the midpoint, and decide which of those, or indeed both, might be the limiting factor. So I'm not going to go into this in detail, but just freeze the frame if you're interested and have a look at that and you'll see how that works. Now, to take off in lower than what you would call normal visual conditions, we have to have the paravisual display in most countries in the world. And the way you do it is you insert the ILS manually on the nav radio page, as I've shown here. And at some stage, you push the PVD knob to arm the PVDs on both sides. And they unshutter a few seconds, they wig-wag backwards and forwards, and then they will disappear. But they are still armed. It must be stressed that this is an aid only. Your primary guidance will be the runway lighting itself. Taxiing out can actually be the most challenging part of low visibility operations. One tip is to use the nav display to ensure that your compass heading agrees with where you should be going on the chart. Make sure also that you understand what taxiway signage is telling you. The inverse Yankee here in the picture shows that you are on the Yankee taxiway approaching taxiway Zulu Juliet. Switch on your TCAS early so that you've got some feel for aircraft coming in and departing on other runways. And of course you may have RAAS as well. Now strobes should generally be switched on when you're crossing runways and off when you leave them. Don't put your landing lights on because a lot of people assume that means you are about to take off. As you come towards the runway, all the lights on if you're cleared for takeoff, and as you taxi onto the runway, just make sure you are on the correct runway. Check the runway heading, the alignment, check the ILS comes central. Always a good idea to tune in the ILS manually in a case like this. Lining up on the runway then, make sure the approach is clear. TCAS is absolutely vital here. Make sure nobody's on the approach and you've got your ILS tuned in, and then as you come on the center line of the runway, the ILS should come central for you. When you get within about 45 degrees of the runway course, the PVD should unshutter, and so on and so on. Just basically make sure that you are in the right place for the runway that you're required to be departing from. I'm going to show you a little short video here just to show you also how the PVD unshutters. You see it just unshuttering there, and as the aircraft lines up, that's the sense that you get from the left and right indication from the PVD. And to show it in a bit more detail now, here we have a little bit of a run down the runway just to show you how the thing reacts. The aircraft's going slightly to the right, so the PVD goes to the left, and the pilot makes a correction to the left. As you can see, when he's done that correctly, the PVD centers. He's overcorrecting the other way now, so the PVD goes to the right, and so on. But I think you get the idea of how this works. So takeoff in fog has to be thought about anyway, but an RTO even more so. The main thing, of course, is that accurate steering is essential. You'll be stopping for the same sort of things. There's no need to prioritize other items. One thing about stopping is, of course, you don't really know where you are, so use the nav display to show you where you are on the runway, but also you may find that you've got coded red, white, center line lighting at some of the major airports. 900 meters to go, it goes red, white typically, and then with 300 meters to go, it goes all red. How much of that you can see will, of course, depend on the day. You may find that other guidance may be available to you depending on what country you're in. One thing is, it's always worth thinking about maybe calling a mayday. Once you come to a halt, set your park brake, think about a mayday. Nobody knows where you are. There might be an aircraft about to take off behind you, which is a very good reason for checking your TCAS before you take off to make sure the guy ahead of you has actually got airborne. Red lights, etc., the usual things for stopping. Nothing really has changed, but once you do come to a halt, just think about what you're going to do with your aeroplane. Are you going to try and taxi off? Probably not a good idea. Are you going to evacuate the passengers into thick fog to be run over by fire vehicles? Probably not. These are things worth thinking about. Always make sure you've got the park brake set, because you won't be able to have any visual cues outside maybe to tell you if you're moving. And start the APU, because the fire crews, when they eventually find you, will want you to shut the engines down so that they can check over the aircraft. This is general stuff. It's not really associated so much with fog, but perhaps worth mentioning. And finally, you've got airborne. You're on your way. So let's now look at criteria for landing. Certain faults can prevent an auto land. Some will prevent an auto land completely. Others will prevent a Category 3 auto land. It's worth taking these possibilities into account when considering your options. For example, a diversion. What if on your diversion to a foggy airport you get one of these issues, for example? The other thing is that having arrived at your destination, make sure you know what the runway is going to look like. Have a look at the chart, make sure you know the width, the length, the slope, the lighting, and so on. And as well as that, turn-offs. Don't go up a blind alley. Go into the charts, work out your landing distance, and that should be accurate, bearing in mind that an auto land generally uses a little bit more runway than a normal landing would. Use the auto brake setting. There is the possibility of an approach ban in low visibility. It's a legal thing for the country that you are in. Sorry, Donald. Might be ICAO, might be USA, India, Japan, for example, have separate rules. And if we look at that in a little bit more detail, it boils down to a cut-off point on the approach at which you make a decision whether you are going to continue the approach. Now, in ICAO, typically it's 1,000 feet radio. In the USA, for example, they use the final approach fix, but whatever, it's about the same place. And the idea of this is that a decision is made well before you get to the runway as to whether you are going to continue the approach. And the rules are these. Above 1,000 feet, you must take account of visibility given to you from whatever source, the tower, ATIS, whatever it is. And if the visibility is below your limits, then you cannot continue below 1,000 feet. However, once you get below 1,000 feet, you can ignore any visibility information that you're given and just carry on with the approach, which is great because it takes a lot of the thinking away from you. When you think about it, it doesn't matter to the aircraft, it hasn't got eyes. You will simply fly down to your limits. If you can see, or might not be required to see with no decision height, then you just go around again. This is not to do with safety, it's to do with the expectancy of the aircraft to be able to complete the approach. There is a proviso to this that below 1,000 feet, even though you're ignoring the visibility at that stage, if you now have a technical problem, which means that had this happened above 1,000 feet, you would not have been able to continue with the approach, then you must nonetheless go around. And that also includes any unserviceabilities at the airport. More mind games on landing. The midpoint RVR comes into operation yet again. Feel free to stop this slide, but again, you have the midpoint RVR to think about. A quick talk about landing categories here. The general limits are listed here. I'm not going to read them all out. I'm going to show you slides in a moment of the sort of visual requirements we have for each approach. A little chat about Land 3, Land 2, Cat 3, Cat 2. This kind of stuff just really refers to the 747. Other aircraft will have slightly different classifications and descriptions. But basically, Land 3 does not mean Cat 3. It means 3 autopilots are operational. Land 2 does not mean Cat 2. It means that redundancy capability is reduced and often you are using 2 autopilots. So basically, if you have Land 3, all autopilots are working, everything's fine. It's what we call fail operational, because a single fault will still allow auto land, which would be enunciated as Land 2. Now, Land 2 is what we call fail passive. You can have a single fault, okay-ish, but for a serious fault, you are going to get no auto land message. And the system looks after you to reduce your workload. For example, below 200 feet, if it was going to give you a Land 2, it won't even tell you because it's just going to get on with the business of landing. A lot of the philosophy is to keep it simple for the pilot. Visual requirements for landing then. Let's move and have a look at Cat 1 to start with. A little surprising maybe, this is actually lovely Cat 1 weather. All you need for Cat 1 is to be able to see any part of the runway or its lights. So for example, the slope indicators on the left side of the runway here, if that's all you can see, or just a few edge lights, that is perfectly okay. So that's actually a lovely day. And Category 1, slightly murkier here, again, perfectly acceptable. You can see where you're going to land the aircraft. Now when we get to Category 2, you need to have 3 consecutive lights, in this case the approach lights and a lateral element. Category 3A, which would typically have a decision height of 50 feet, you would require 3 consecutive runway lights, and these would be actually over the runway as well. And category 3B, which would typically have a decision height of 20 feet, you would actually only need one light. Now, if you get to 20 feet and you don't see a light, you're supposed to go around, press the togas and do all the good stuff. The aircraft might touch down while you're doing this, but it will get airborne again, they tell me. And lastly, no decision height at all, Cat 3B. The minimum for this would be 75 meters typically, and the aircraft does not have eyes. It doesn't mind that you can't see anything at all, though it might be slightly unnerving for the pilot. The only reason you need 75 meters is to be able to taxi clear, or for the emergency services to find you if things don't go quite according to plan. So what could possibly go wrong? Well, there's a little list of them here, which is a favorite from all trainers and instructors. The guys get below 1,000 feet and they'll give them one of two, even two of these things to deal with. And typically they'll either go around or land. Some here would require a go around. An auto throttle failure is not a big deal. You simply carry on and close the throttles yourself. But remember, if you do a go around, you're going to have to open them up as well. Engine failure is an interesting one. I'll deal with that very shortly, but basically the aircraft looks after you for an engine failure. Radio altimeter failure as well. You'll typically get the aircraft giving you a land 2 indication or worse. ILS deviation, I've got a little video to show you as well. Now, wind out of auto land limits is a possibility. The wind limits aren't terribly generous for an auto land. They're listed here. In particular, I would draw your attention to the crosswind requirements in the USA, which is only 15 knots. Now, having said that, it's not often you get fog at 15 knots, but you know, we could be talking about a sandstorm or something. Who knows? So it's just worth bearing in mind these figures. Here's a little video of an ILS deviation indication. You see what happens. Basically, I put in a big crosswind to make this happen, and the aircraft starts to bank to take care of it. Above 200 feet, you can watch it and see if it's going to recover. But if by 200 feet you still deviated, then you have no option to go around according to most SOPs. One thing I'll point out here, notice that the aircraft is following the ground track that it had at the time, which is a very, very good reason for 400 feet, making sure you go to a sensible mode, such as I've selected here, heading cell. Otherwise, you'll be heading off into the jungle somewhere. So that was the ILS deviation. Okay, let's talk through a fairly eventful approach here. We're set up with 300 meters RVR, but we've set for our lowest minima, which is actually 20 feet, so 200 meters really, with 20 feet radio, and the captain's FIS selector for minimums is selected to radio. It's the captain side which decides where the call out comes from. We've got approach selected, of course, and we've got 3 autopilots lit up, but note that we are not yet in multi-channel because we haven't got land 3 or land 2. We've only got command. So we're now running the simulation, and I've failed an engine. No rudder goes in. See that? At all. The aircraft starts to bank, and now we've got multi-channel. The aircraft notices that we are asymmetric and it applies rudder. It does not, however, change the indication on the rudder trim indicator, and this is a real catch out. Pilots can sometimes wind on the trim, wind on the trim, wind on the trim, and it doesn't show, which is actually very dangerous. So here we have land 3, flare and roll out arm, and we are above 1,000 feet, so we have to take into account any runway visual range that we are given at the time. But as we get to 1,000 feet, we are now able to ignore any weather information that we are given, even if the RVR is 0. However, if we have an unserviceability as we continue this approach, we have to change our minima or go around if we haven't got that visibility. So let's see what happens next. We've actually lost an autopilot up here, see that? And we have land 2. Now it'd be nice to be able to rebug for our new category 3A limits, which would typically be 50 feet. But in fact you can't do that because the scale has gone. You could go in the FIS and do it, but frankly that's a complete faff and not a very good idea at this height. So this is where the Non-handling pilot would have to start calling out manually 50 above and decide for your new minima. However, with land 2, the autopilot is looking after the engine failure, and we are flare and rollout arm as normal. Below 200 feet now, anything further that happens, the airplane simply won't even tell you.
100.
50 above.
So we have
50.
land decided,
30.
the aircraft is
20.
flared,
Decide.
the throttles come back to
10.
idle, and the rollout. The autopilot is still in, the auto brakes are taking over, the nose wheel is flown down to the runway, and typically in a situation like this you would select just reverse idle. You certainly don't want asymmetric problems on a rollout. So in summary, chronologically, additional flight planning is required. You've got rules for takeoff, things to think about for RTO. Destination planning needs to consider weather and serviceability issues, and landing also has rules. Or you could just ignore everything you've seen in this video, press the button, plug it in, and have fun in Flight Sim. Thanks very much for watching the video. Keep watching the credits at the end because my finest hour is coming up. Thanks very much. Bye for now.